Hello, this is graphics. So this is quite similar to sound in many respects. So what do you need? You need OneNote. You've got this presentation. You should have a graphics worksheet, which is there. The homework you all have, and there's some A-level questions there as well. So also the summary sheet, which is that. Okay, so you've got a fair few things to do. So first thing, bitmap graphics. Okay, so basically what the bitmap graphics, what you've got is pixels, and pixels short for picture element. Okay, not many people know that. And you can see it's made up of blocks. So everything's made up of pixels, but you have bitmap graphics and vector graphics, which we'll talk about the difference between the two in a minute. Then we have a resolution. Now, resolution can be thought of as two things. It's the width and the height of the image. We always start top left, okay, or it can be expressed in dots per inch, because when you've got a high definition TV, for instance, which is 1080 by 1920, like that. Obviously, if that's on a 50-inch display or on your phone, it does make a difference, okay, because you've got close to your TV, you're going to notice the pixels where you wouldn't necessarily notice that on a phone. So the dots per inch obviously do make a difference as well. Okay, so what we got here then, so for example in this image here we've got 1024 by 9798, multiply those two together and we end up with how many pixels. So obviously if we've got 1080 by 1920, you can do the maths on that. It's quite a lot. I'm going to use my phone, and it is a number. Okay, so it's about 2 million pixels. All right. Let me just do that again because that seems wrong. 1080 by 1920. Yeah, it's 2 million. So it's roughly 2 million pixels. Okay, right. So there's the resolution. As I said, it can be expressed in either the width times the height or the dots per inch. Now, bitmap graphics. Now, what we're essentially doing there is we're storing in memory the color of the actual each pixel. Now, if it's monochrome being just two colors. Now, it doesn't have to be black and white monochrome. It can be just any two colors. But generally speaking, we think of it as that. Okay, so what we could do is we could just have 0 for white, 1 for black. Okay, and that just means that 1 bit will be needed for each pixel. All right, so if you imagine up here, scrolling back up here, you could just have 0 for 0, 0, 0. This is too small, isn't it? Okay, so that's 0, and let's pretend that that's black there, so that's going to be 1. All right, so that's easy. The nice thing about that is it doesn't take up much memory because it's as I said, it's only two colors. Now, if we want more colors, then we're going to have to use more than 2 bits per pixel. So in this case, then, if we use 2 bits per pixel, that's the range. So we go, I've done it in an odd order there, but so 0 is black, while 1 is white, or 3. So that's basically 2 to the 2 equals 4. Therefore, you can have 4 colors. Okay, and that is the number of bits. Following from that one, 2 to the power 1 equals 2. Okay, so 2 colors. So as you can see, if you add more bits in memory for each pixel, then you can have more colors. Okay, now that is called the color depth. So we have 1 bit color depth, we have 2 colors, 2 bit color depth, and you can see there that white there is that one. I think that's why I've counted it up in different, because this is taken from one of the textbooks. All right, so you can see 0, 1 there is blue and so forth. Now, so this is taken from PowerPoint. So this, if this was in class, this would be revealed as we go along. So for 3-bit code, 2 to the power 3. For 12-bit code, 12. General formula is basically what I've just said. And you will see 24-bit, sometimes called true color, I think it is. So 2 to the power 24 equals, let's have a look, 2 to the 24 is lots to is equal to 16 million. Okay, 16 million 777,216. So that is using 3 bytes per pixel. 3 bytes. Okay, 3 bytes per pixel, and that's your true color, and that's one of the settings you get now. And if you use 2 bytes, 65,000. Right, I've really sort of ran that home. Right, so let's see about calculating image size. So what we need is Microsoft Paint. There we go. Now the important bit is we've got I haven't used this for a while, so let's just change the image size. Alright, well that'll do. Now if I do an image on here, I'm no expert on this. Actually I can use my pen, so at least I can do something. There's a house. Do a bit of filling. Where's the fill tool? I don't know. I don't know what that is. It's a dropper. No. Anyway, there's my image. All right. So what we have there is 1084 by 789 pixels. Now, if I save that, so I'm just going to write that down. By 689. Now I'm going to save this image. File, save. Just save as actually. So I've got to save it as a bitmap, not a JPEG, because JPEG will compress it. And then I've got some options there. So 24-bit bitmap, that's too much. Let's go for 16 color bitmap. Now 16 colors. How many bits is that? Well, what that's going to mean is that there's going to be, well, we'll talk about that in a minute. So 16 color. Now I'm going to save that on my desktop so I know where it is. Right, I'll call that desktop. That's okay. We can cope with the loss of image quality. Now, so just to quickly go back to that one there, what we had. So what we had was an image like that. So it's 1084 and 689, going like that. Okay, right. Now it said 16 colors. So what that means is 2 to the 4 is equal to 16. So therefore, it's 4 bits per pixel. Okay, so how do I work that out then? So what I'm going to do then is I want to know how big this image is. So it's 1084 times 689 times it by 4. That gives me the number of bits. All right, I want the answer in bytes, so I'm going to divide it by 8. Okay, now I might need to divide that again by so to get it into kilobytes. So 1084 times 689 times it by 4, and what's that equal? So that's 2.9 million. So divide that by 8. Right, now that's something more like it. So it's 373,000. So divide that by 1,000. So divide it by 1,000 again. We get 373 kilobytes. So I'm going to divide that by 1,000 and I get 373.4 kilobytes. All right, now let's have a look to see what it actually is. There it is there. So properties, and it's 366. Now the reason for that is because Windows is using the old 1024 bytes as a kilobyte. Okay, but you can see it does actually give you the accurate answer for that. Okay, now right, let's go back to what we were doing. So calculating image size. Well, I've just done an example, but there's another example, so that's a nice easy one. So number of bits per pixel. So you've got to basically remember is you've got the dimensions, you then times it by the bits, divide it by 8 to put it into bytes, and it's easy as that. Okay. Now we'll go back and have a quick look at that image in a bit later, but we've got vector graphics. Now these are basically coordinates of images stored, so it's basically objects and properties. I think that's the objects, and they have those properties. Okay, now so what we need to do is have properties of our objects. So our objects can be things like circles or ellipses, a bit more flexible, that's bad writing out, rectangles, lines, and so forth. We just give them properties. So for instance, the ellipse would have an x and y coordinate, the radius, the fill color, the line color, line style. So there's all of these properties that will be applicable to that. Right, that's the worst image as well. Now the thing is with this, what you can do is with vectors, you will just, if you enlarge it, it'll just draw it bigger. Whereas you try that with a bitmap image, it will just become pixelated. Now a bit more on compression. We had a quick look at that last time. Now it does tend to make a lot of sense using compression. It does, because often you will get, if we go back to my paint here, you know, there's an awful lot of exactly the same color there, mainly white. I'm trying to think of my hex editor, which I don't think I've got installed on here. Now so I could show you but what it looks like. So what we've got then is lossless, which is your run length encoding. So you can see there the top line, rather than having, now you don't think it's just, so maybe that's the top line and it keeps going. Yeah, so that run of blue would go multiple lines. As far as the files are concerned, it makes no difference about that. Okay. Now the top line, so rather than having 100 continuous menu locations of the same color, we can just have, right, number of pixels, which is 100, that's 100, and then that's the color code for blue. All right, and that will significantly cut down the amount, especially if you look at that one I just did then. Lossy, on the other hand, is a bit like MP3 for sound, so that reduces, you won't get back to the same image quality. All right, so JPEG, but you can have lossless compression. PNG files, for instance, are that. Okay, so that covers most of it. I might do a little extra video on the file structure of a bitmap in a minute, but just going back now to what you've got here. Now you've got this graphics worksheet. Okay, now essentially what that is you're going to be looking at that and going, right, the idea was you'd be converting this image here into binary. All right, and you do that by going, right, okay, so I'm going across here, going like that, and that basically is the same here. So that pixel, that square there, is that one there. Okay, and I just keep going across. So is there anything in the first one? No. Is there anything in the second one? No. Is there something in the third one? Yes. And that's basically what we're doing. Now it says there, could you create the image from the data in the file? The answer is no. Okay, and because it's missing some crucial information, which will be in the second video on this. Okay, so you'll not need to come back to that. The second one, now this does have the crucial information because I've provided you with that. All right, there's one on vector graphics. So it's saying, what do you need to store about this circle? Or just need to store about the line? And then there is this. Now the idea of this is it's not giving you too much information, but it should be fairly straightforward about what's happening. All right there. So what would you need to store about a circle? Well, I'll tell you, for all of these, you've got some coordinates. So 3, 3 could well be the coordinates. Okay, the 2 could equal mean something. Well, it does mean something, and the 1 means something. So you try and work that one out. Okay, you've also got this. Okay, so what you've got here is you've got some questions on bitmap file sizes. So let's just quickly have a look at the first one then. So there's an example. Well, okay, come on, let's go through examples. So we've got 768 by 1024, which means it can display 16 colors per pixel. So that's like the example we just did. So it's 4 bits per pixel. So we're multiplying that, divided by 1000, and getting it to kilobytes. Now the rule of thumb is basically you get it into a smallish number by keep dividing it. If you still get, if you get over 1000 there, then you could divide it by another 1000 to get a smaller number. So if that was too big, you could, if that was like 2000 kilobytes, you could divide it by 1000 again to get it into 2 megabytes. Next one then, this one uses 32-bit color bit depth. So basically what we're doing here is we've got 1080 by 1920, so 1080 by 1920 times it by 32. And then we've got divide it by 8, and then divide it by divided by a million, and put it in megabytes. Yeah, is that the right number of noughts? I believe it is. There's also another one here. How many different colors can the image show? So that's 32-bit color. So you need to think about that, and then that's working out that one. I don't need to do any more on that, I don't think. Right, okay, I'm going to stop that video there, and then I'm going to do a little extra one on what's stored in the file. Okay, so you've got the homework, which is that one, and you've also got these A-level graphics questions here. Now it'll be on Teams what I want you to do. Okay, so that's that one done.